Hello and good afternoon. Thank you for joining the Bipartisan Policy Center for our fourth webinar in our series, Getting Serious About Housing Supply, focused on different facets of our country's housing shortage and what can be done to fix it. I'm Erica Young, the Associate Director of the J. Ronald Terwilliger Center for Housing Policy at the BPC. The center was founded to advance the goal of a decent, safe, affordable home for every American family, recognizing that housing is more than shelter. It provides significant social and economic benefits. The lack of housing supply has led to rent escalations of up to 40% in some cities, including places like Austin, Texas, and Portland, Oregon. According to CNN, home sales prices are up 17% nationwide. There are several factors contributing to the shortage in housing, including, but not limited to, supply chain issues, rising land costs, local land use and zoning restrictions, and labor market shortages. Today, 4 experts are joining me to explore recent innovations and technological developments with the potential to bring greater efficiencies to the construction process and reduce the time and cost of housing development. We also hope to touch on the role policymakers at the federal, state, and local levels all have to play in supporting housing innovation, from addressing building codes and regulations that limit dissemination of new processes and materials to funding innovative research and supporting entrepreneurs. We're going to kick things off with some short presentations on some of the most promising innovations before turning to questions and answers. At any time, please feel free to comment or add comments or questions in the chat if watching live on YouTube, or tweet at BPC_bipartisan, or using hashtag BPC Live. To start us off, I'm pleased to introduce Andrew McCoy, Director of the Virginia Center for Housing Research at Virginia Tech, who will summarize some exciting cutting-edge developments now populating the construction landscape.
Well, good afternoon, everybody. Thank you so much for having me. Thank you to the Bipartisan Policy Center and the Terwilliger Center as well. As Erica wonderfully introduced me, my name is Andrew McCoy. I am the director of the Virginia Center for Housing Research. I'm also a professor of building construction and the associate director of the Myers-Lawson School of Construction. So today my goal is to give you a large overview of the technology and the advancements in the construction industry at large, while also focusing on housing specifically and how we can leverage technology possibly towards driving down costs. I'll start off here by just showing you, and I'm going to break down these topics into 3 different areas or sectors, kind of the current market, technology on the horizon, and the final one is digital transformation. In the current market, we're seeing that even in the residential industry, which historically has been a little bit behind the commercial side of the construction industry, we're seeing that business management systems are becoming very common. It's a great way to interface with clients. It's a great way to share and have more efficiencies in terms of the construction process, scheduling, costing, all of that side of the industry. So in the current market, you're seeing a prevalence of that right now. But also I wanted to point out as a baseline that everything I'm going to tell you about, all the technologies, a lot of what makes them impactful and possible really is building digitization and information modeling. So in the construction industry, we typically, we often use a platform called Revit, or a software called Revit. But increasingly what you're seeing is the ability to have more dimensions than just the 3 dimensions of the modeling. So you have 4 dimensions and 5 dimensions. You might have cost and schedule now added, and we're going into other dimensions as well. But I wanted to mention that as kind of a basis for a lot of what I'm going to talk about today, and maybe as the panel will talk about too. Okay, so in terms of the current market, we're seeing that there's really, what we might have considered manufactured HUD code building before is really becoming much more of an industrialized, and it has been for quite a while, but we're seeing much more permanent manufactured construction where modules will come fully suited. And I know that a little bit later, Mark's going to talk to you more about this, and I'll let him get into the details and all the definitions. But we're seeing much more of our housing that can be produced in a factory setting at many different levels of completeness and with different trades all wrapped into one, and it's ready to go when it hits the site. So to that end, we're seeing a lot of off-site and modular construction trends that are just continuing to grow in terms of the options that are out there. We can panelize many different parts of the construction process long before it gets out onto the site, and we can have it ready. To the right there is an image of structural insulated panel systems. So it's a highly insulated panelized system that comes onto the site ready to go and fits into place very nicely, and makes for a very tight construction that has a high thermal envelope. So, but we have all kinds of different versions of panelization, and these are all part of the industrialized housing process. All right, and I wanted to mention some other parts of the industrializing of the construction site or the housing process. We have, for example, prefabricated just elevator cores that now can be lifted onto sites to save time and construction costs, often because they're built off site. You have entire parts of buildings that, and this has been happening for quite a while, that can become modular and just fit into a larger construction process, like the bottom right that you see there, with, say, for example, precast elements of a building. And then in the upper right, we're seeing that the actual process on site more and more, and this is a ducting contractor, a mechanical contractor who's prefabricating all the ducting. So they've gone into the building, they've done a complete scan, and they've created a model of the building. They know exactly what this ducting should look like, and they're printing it out, and then they're going to have it delivered to the site and installed. It reduces time, it reduces costs, and they can do a lot of the work off-site. And one of the other things I want to touch on in the current market is we're seeing a lot of geospatial technologies where we're able to identify and understand what's happening, not just in the construction site and what we're going to put above the ground, but also what happens below the ground. And increasingly, as you can imagine, especially in urban settings, this is becoming more and more congested. So we're really able to understand and design out and then overlay, and that's what you see in the bottom left of your screen. We can overlay all of this information onto the site, and it becomes much more of a digital representation of what is there, what's beneath the site, what's going to be on top of the site, all these different sides to it. All right, now I'll get into technology on the horizon. In the top right there, you see what we call mass timber, or cross-laminated timber construction, CLT construction. And this is where we're seeing wood-based construction technologies going many, many stories higher than we have previously seen. These are great fire assemblies so that we can actually typically put the wood panel and expose it and still be able to meet fire code in different types of building construction types. And so it's a very exciting technology. There's a lot of information out there on it right now. And what you'll see is that the wood construction technology, which basically helps us avoid some of the cost of concrete and steel construction, that's going up 20, 30 stories now in some cities. So it's a very exciting future of where things are going. It's a little bit on the horizon, though. A lot of the details are of how the engineering and how the wood structure comes together. That's where it takes a lot of expertise and people are trying to figure it out. I think you're going to see, and you are seeing on the horizon, a lot more around additive manufacturing and digital fabrication. So it's all the way from the house on the bottom right, which is a house that Virginia Tech worked on with a company called Alquist and Habitat for Humanity in Williamsburg, Virginia. It's the first owner-occupied, affordable 3D concrete printed house in the country, and honestly, I think in the world. So you're going to see the ability to print housing and parts of housing. And then on the left, I'm showing you the way that we can do mass customization now too. We're starting to see parts of the house itself that can be you can customize them, but they can be mass produced through digital and additive manufacturing. I'll give you an example. Each one of these houses that is printed by Alquist there on the bottom right comes with a 3D polymer-based or plastics-based printer that allows you, if you break a handle or you break a switch plate on the wall, you can just plug in the USB and it'll print a new one for you. So we're seeing a lot of that in housing. Also, we're seeing a lot of robotics, right? So you're seeing that, especially as labor continues to be stressed, you're seeing that robotics are starting to be able to lay brick, lay concrete block, help workers in terms of stress and strain that they might have on the job site. That extends their life cycle and ability to work later, especially if we have a lot of retirements and people on the site are needed more and more, and we don't have as many people entering into the trades. This is very helpful. And then you have the ability on the bottom left of the screen there for robots to go into much more unsafe settings and be able to do work that in the past it was more difficult to do, and we can save money by using robots there as well. All right, on the horizon, I think what we're going to see is that you're going to have a lot more remote construction. I think the pandemic really brought this about as well, but those technologies through augmented reality and virtual reality, where you can really kind of see what's going to happen on the site, work through the digital environment, work with positioning of equipment, work with stockpiling, work with site settings, and really keep a track of surveying what's happening on the site at all times through drones. And that's increasingly happening as well. You can also figure out what's happening with workers and how workers are moving across the site, especially for unsafe conditions, things like that. And that's through the RFID tagging process. And then here's where we might be going, really, this idea of digital transformation, that we kind of have a digital imprint or footprint for all of the buildings above ground, underground that we see on the horizon, and increasingly the buildings that are being operated in the current environment. So that allows us to actually step within a building like you see on the bottom left, put on some virtual reality headsets, and be able to work through solutions right there, possibly remotely, but also in place to understand how the building might work. But in that process, we're also able to start collecting more and more information about buildings, how they're functioning, how they're operating. So the life cycle of a building, where a lot of the cost longer term, we can start to understand how to bring down those costs. And what you see here is for one building that we recently studied. You can look at a lot of the different operations in the building, and with the amount of data and the machine learning that we're seeing in the construction space, you're starting to be able to predict when you're going to have certain failures of equipment, things like that, because you can see patterns over time. And you can also look at items like energy usage and affordability and start to work with spaces, understand what makes for good spaces for working or for learning or healthy spaces, and also be able to help drive different conditions that would mean more affordable operation, which means affordability that's passed on hopefully to the resident or the person who's in that building and owning that building. And then I think finally down, we're seeing this really on the horizon. It's some of our PhD work that we're seeing more and more is this idea of computer vision. So if we can have image-based 3D models that identify, especially in terms of automated cars and other vehicles, unmanned vehicles, can we translate that now to the construction site where we can understand safety, we can understand quality, we can translate that to quick scans, and on the bottom left, that's where you see a wall where the computers can start to learn where you might have some failures that are some cracking that might become failures, or cracking that's actually just more cosmetic, and you can start to teach the computer more and more what we're looking to see, and we can continue to monitor. So just real quickly, if we looked at kind of innovation in the regulatory landscape, what conditions are favoring innovation right now? Material, labor, and supply chain costs and delays are very prevalent. You hear about it a lot, and it's a problem. Housing availability and cost is something that's really driving the need for innovation in this space. Inflation, of course, is a concern right now. And then really, because of those three, we're seeing that the market is very open to innovation like never before, especially in housing, where you have a younger generation who really needs housing, needs starter level housing, and they increasingly are interested in technology. What kind of progress have we seen? Well, building codes have been written at the national level for modular construction. We're seeing changes in building codes that look at manufactured housing as well. It's great, but especially in the manufactured housing realm, we're seeing great finance options that are starting to open up. Builders are actively looking for ways to reduce costs right now. And they always are, but I think in right now it's especially acute. And the market is accepting of different types of housing, both builders and customers. We do still have NIMBY. We have all levels from zoning to public sentiment. Innovation is risky and expensive, and we need people willing to experiment. Innovation needs investment, public and private, and that's something that's tricky, and what we can maybe talk about that a little bit more later. And there's a lot of interest in the construction technology market, or con-tech we hear, in terms of investment. And so what that often will bring is exaggerated claims of success. So I think we have to be careful in this space and make sure that if an innovation doesn't work, we don't wipe out all the hope for other innovations as well. One of the things that I want to just kind of bring up quickly is the policy landscape. What's exciting about innovation is it creates benefits for consumers or market spillovers, and then the knowledge created by one firm creates value for other firms or customers, right? We call this knowledge spillovers. But and the combination of these would be what we call a total social return from an individual firm's innovation. The problem is that often firms feel like that actually helps or means that they lose market if others find out about their innovation and what they're doing to make themselves successful. So there's really no perceived reward for improving the products in the market necessarily. So what can the government do to help? So here are just some thoughts from me and some of the work that we've done. Supporting basic research is very important. Industry-based research as well is very important, in having support mechanisms that drive kind of applied sides of the basic research that we do. A lot of non-financial support for industry research is very common, especially from the government standpoint, and it's wonderful. Keeping that going and making the conversation continue is really important. And then there's the need to commercialize certain technologies, so support for development and commercialization increasing, and we have some great programs right now that are ongoing, but continuing to kind of drive that and help the industry push innovation forward is really important. And I believe that's the final slide for me. So I want to thank you so much for listening to me, and I'm going to pass it on to my other great colleagues who are going to talk about different parts of the industry.
Thank you, Andrew. Next, I would like to introduce Judith Scheine, a professor at the University of Oregon and director of design at the Tallwood Design Institute. Judith, thank you.
Thank you. I'm trying to get my slides up. I'm sorry. I'll go back to the beginning. My apologies about this, but my internet clicker is not working. There we go. Okay, so in Oregon, like in many places in the US, there's an enormous shortage of affordable housing. And the legislature decided to be proactive about this by passing a bill called Oregon House Bill 2001, essentially getting rid of single family zoning in the state. But they left it up to individual cities to figure out how they were going to densify these areas. And we've been working with the city of Milwaukee, Oregon, which is just outside Portland, who's been very proactive in developing zoning for what they call cluster or middle housing. Middle because it's between single family and multifamily housing. But in Oregon, there's another piece to this equation, which is mass timber, which you just heard mentioned. And in Oregon, there's been a huge loss of jobs in rural communities due to a reduction in logging and due to automation. So there's an enormous amount of interest in reviving the timber industry through the development of cross-laminated timber and other kind of large mass timber products. And these products can be made from small diameter logs that are sourced from forest restoration projects, which have co-benefits of wildfire reduction, another huge problem on the West Coast. So our institute, the Tallwood Design Institute, which is a collaboration between the University of Oregon and Oregon State University, has done a lot of work in advancing and kickstarting and advancing this mass timber industry, or the industries in the state, including over 50 research projects, of which I'm going to show you 2, and also in developing a new product called mass plywood, which is made by Frere's Lumber in Lyons, Oregon. While we've been able to get cross-laminated timber and mass timber to compete quite well at larger scales, it's very hard to get it to compete well in terms of cost with small scale housing. So, however, with mass plywood, which can be made in 2-inch and 3-inch panels, much thinner than CLT, which is typically the thinnest is about 4 inches, taking advantage of the possibilities for prefabrication using CNC equipment, which wood panels lend themselves to. We're designing panelized housing in Milwaukee using thin MPP panels that we think we're just about there in competing with light wood frame, and being able to take advantage of the tight thermal envelope for energy savings at the same time. So we're working on a pilot project in Milwaukee with Homework Development, an affordable housing developer, and Providence St. Joseph Health System. They have a hospital there in Milwaukee. They have a lot of concerns about housing affordability for their own staff. And they want to create a pilot project for healthy housing. So we're doing a pilot project of about 34 projects, 34 units, excuse me, in Milwaukee. You can see a site plan here for 3 of them that the 2 sites on the right are actually owned by Providence, which they have given to this development, along with some development funds, because they're very interested in seeing this succeed. And we've been working largely on trying to really make this affordable. So we've been working on making a very, very tight and efficient site plan for 2-bedroom units, which are repeatable. They're going to be singles and duplexes. And we've been working on reducing the amount of panel that we use. We took the height down of the gable to do this, and we're looking very carefully at how much panel we're actually using, how much volume of wood we're using, both outside and the panels that we're hoping to use inside as well. And taking advantage of prefabrication and factory techniques that you just heard a little bit about. And we're working on a second project, which is about looking at retrofits, using essentially the same technology for doing retrofits of affordable housing. There's an enormous amount of housing stock built in the 60s and 70s on the West Coast, light wood frame, 2- and 3-story multifamily housing that's desperately in need of energy retrofits. And originally there was an RFP put out by the Department of Energy for looking at CLT wall retrofits for energy efficiency. And we decided to take that challenge, but also make it about seismic retrofit at the same time, which is desperately needed on the West Coast. So we're working again with thin MPP panels, and with one of our partners in Oregon State University's College of Engineering, Andre Barbosa, to develop, again, prefabricated panels that can be used, hoisted up in place and attached to buildings without much disturbance to the current residents. We actually are completing a mock-up now. This is actually, these are shots from just this week in our lab, where we actually have been seeing these. We actually am using wood fiber insulation with a 2-inch panel and seeing it, cutting it out, digitally fabricating all at one time, and then applying some stained plywood cladding. And these will actually be lifted up into place on our mock-up next week. And we hope actually in both of these to be able to prove affordability, because we know cost is a huge issue, as well as, reducing time of construction through prefabrication. Thank you.
Thank you, Judith. That was great. I would like to now turn to Mark Bowersox. He is president of the Manufactured Housing Institute, and he will be providing an overview of how the Manufactured Housing Institute has changed and its role in expanding housing supply. So thank you, Mark.
Thanks, Erica. Thanks for having me. Also, thank you for the Bipartisan Policy Center for putting this on, as well as the Terwilliger Center. I'd like to talk a little bit about the manufactured housing industry across the United States. Manufactured housing is by nature a federally regulated industry and makes that term unique to the United States of America. It's not a term that fits in any other place around the globe. There are 22 million Americans that live in manufactured housing right now. We are generally about 9% of all new single-family home starts over the course of a year. That puts about 8.5 million manufactured homes across the country. They are built in 140 different plants spread throughout the country. And last year we built as an industry over 105,000 manufactured homes. Generally, people are happy with them. The homeowners, 90% of them are satisfied. 71% of them cite affordability and attainability as a key reason why they purchase their manufactured home. Our industry is significant in the south and southeast parts of the country. You can see these are the top 10 states where manufactured housing homes are sited. This is last year's data. Those 10 states equal a little bit over 60% of the annual shipment. So it's a 20% of the states get 60% of the homes kind of a scenario. And we'll talk a little bit later about why that may be. Manufactured housing, I want to go back to what Andrew teed up for me a couple of presentations ago. Manufactured homes are built to the HUD code, and that is the HUD code that's been in effect since 1976. Prior to that, these types of homes were considered mobile homes. And so when the HUD code went into effect in June of 76, all these types of homes that were built to a construction code organized and audited by HUD. And so those homes are now built to a code known as the HUD code, manufactured homes. They're different from modular homes in one key area and in several ways, but the key difference is the construction code they are built to. Manufactured homes, again, built to a federal building code, but governed by HUD. Modular homes are built to a state or regional code, which is governed by the local building officials. And so oftentimes those types of homes are built in the same factory and they can look very, very similar. Oftentimes a manufacturer will offer the exact same home and a floor plan that's governed by the local building department versus the HUD code. But the key difference is that one is the HUD code and one is built to a state and local code. The key to manufactured housing and a lot of the different types of housing that we're talking about today is volume and efficiencies created by volume and efficiencies created in other ways. The HUD code allows us to be efficient because it's one construction code that can go into the entire country, as opposed to a different construction code being built for each state. And so if you have a manufacturer in the corner of Indiana, for example, and they may sell homes into Ohio, into Michigan, Indiana, into a 6 or 8 state region, actually. If they're building to the HUD code, they can build the same exact house with the same exact materials, the same exact specifications, and the same exact construction and safety sections, and that can go anywhere. If they're building that to a modular code, that's going to be a different home with different materials, different inspection processes, and different techniques if it goes to Indiana or Michigan or Ohio, whichever state the home is going to be sited in. Panelized homes, our industry doesn't get into quite as much, but they're homes in which we saw some examples of full panels being transported, as well as pre-cut homes with different levels of factory customization. As I said, one of the key benefits of the HUD code is that they can go into any state in the country through any factory in the country. It's a universal building code. I also mentioned that the HUD code must comply with numerous federal regulations instead of state and local building codes. And there's a rigorous framework of not only code approval, but also inspection process throughout the construction and design process. Here's a few examples of manufactured homes today. Manufactured homes are restricted primarily by the transportation from the factory to the building site. And so you will see by and large skinny boxes that are being transported down the road. And a single section home looks a lot like this today. We also build multi-section homes, which would be a one or more shipments that are pieced together on site. And so you can see a little bit more of a more traditional site-built housing feel. These are both multi-section homes, 2 sections that are combined on site. And now our industry has evolved into cross-mod homes. This is a term that is used. Crossover and modern is where that term comes from. And that is a crossover from factory construction to a site-built construction, because what we're doing in these homes is building the majority of the home in the factory and then adding some on-site features that are just not conducive to be able to do for a home that's being shipped and transported down the road. And so we can build the home in the factory and then add on a front porch or add on a garage or some generally aesthetic add-ons that make the home be able to fit aesthetically in any neighborhood in America. To that point, we're also doing a little bit more as an industry with urban infill. Our industry builds a great product. It has a lot of advantages when you're talking about siting homes in an empty vacant lot, that we can make something that fits right there with the neighborhood. About a third of the homes that our industry produces are sited in land lease communities, where a resident owns the actual home and leases the ground underneath it. It's a great option for a lifestyle. There are many different types of manufactured housing communities. There are all age communities. There are senior communities that all offer a wide range of amenities. And you can often buy a manufactured home and live in a land lease community at a significantly lower cost than owning the ground underneath the home. The quality of today's manufactured home we'll put up against anything. Building materials that are used can be used. Anything that's used in a site-built construction environment can be used in manufactured housing. Our industry generally builds to an attainable home price point. We can do with the factory efficiencies, we can build to a lower price point than any other type of construction. And so that's kind of our sweet spot where we've been historically. But as consumers demand more, we are adding more and more upgraded building materials and more higher quality features. Studies and research have shown that manufactured homes of today perform as well or better as site-built homes during the storms or severe weather. The current manufactured housing regulations require minimum requirements for insulation and anchoring when we actually install the home on the ground. And there are different zones in the country that tend to experience more severe weather, that requirements are more stringent in those areas than they would be for the majority of the country. Let me move on here to the next one. Again, showing that since the HUD code was updated after Hurricane Andrew in Florida in 1992, no manufactured homes were destroyed in the hurricanes in 2004. Affordability, I mentioned, is key for our industry. Last year, the average manufactured home cost is a little over $106,000 compared to the average site-built home cost of over $350,000. There's an enormous affordability gap in all forms of housing in this country, and that's the reason we're all on this call today, right? Some of the key issues for manufactured housing that we can get into as a panel later, primarily are just some discrimination. We mentioned NIMBY earlier. But zoning is a big challenge for us that we'll get to if we have time. Freddie Mac just did a zoning survey and showed that more than 1 million people nationwide are being zoned out of the opportunity for home ownership because of the restrictions on manufactured housing. There's our website and email address. If I can offer any more information, feel free to reach out. I know I zipped through that pretty quickly, but if there are any questions, we're happy to address.
Thank you, Mark. That was great. I look forward to us having a discussion a little more about some of the points in your presentation. And with that, we're moving on to Rusty Smith. He's joining us from the Auburn University's Rural Studio. Rusty, can you briefly walk us through the Rural Studio's innovative work in design and construction and how it's helping to meet 21st century rural communities' needs.
Yeah, sure, Erica. Thanks, and hi everyone. We are engaged in a lot of the areas that we've talked about. I'm just going to sort of talk about one of them that was mentioned at the beginning, and talk about sort of the business management piece of it. So just a little background on Rural Studio. We educate architecture students by working in partnership with our neighbors in low wealth communities in West Alabama. And our work primarily involves the design and construction of both homes and community facilities. The Front Porch Initiative, which I represent here today, really encompasses Rural Studio's ongoing research and development, in which we try to better understand the barriers to equitable housing access and affordability. Building on the applied research and learning from Rural Studio, the Front Porch Initiative, we aim to develop a scalable and sustainable process for delivering homes primarily in under-resourced communities throughout rural America. Our comprehensive approach includes, first, creating products and processes that tie home performance to affordability. Second, we develop partnerships that extend the impact of Rural Studio's housing affordability research beyond our own service area. And lastly, we advocate for policies at the state, regional, and federal level that facilitate equitable and affordable access to homeownership. So addressing equitable and affordable housing access is really a complex systems-based challenge, and the synthetic relationship between these three components of housing products and processes, partnerships, and policies are really quite difficult to consider as separate and distinct from one another. For today's conversation, I'll attempt to focus primarily on the product and process side of the affordability equation. So I'll share just one example of what we think innovation looks like relative to design and construction in our work. So first, in under-resourced rural places, you have to do a whole lot while only having very little. So it's really important to do things right. So instead of relying on a lot of high-tech materials or specialized devices like robots or complex processes like additive manufacturing or 3D printing, instead, we simply try to maximize the potential of materials and resources that are locally and readily available in the places that we find ourselves. And this is where doing things right really comes into play. With our houses, we've refined a multi-step process to ensure the houses meet their intended performance targets, both during and after construction. And for example, to help our builder partners determine the performance standards that best suit their particular homeowners' affordability needs, we first developed detailed comparative energy models of multiple options and scenarios. And then while the house is under construction, we test the house at various points along the way to ensure that it's meeting or hopefully exceeding the expectations predicted by our computational models. If it doesn't, we can quickly address the shortcomings the moment they are discovered during construction. At project completion, we work closely with third-party evaluators to certify the performance of each home. And then we perform ongoing post-occupancy energy monitoring, which allows us to track energy consumption and evaluate it relative to predicted energy use. And as we collect and analyze this data, we can construct better and better predictive models, as well as help our housing partners make better and better decisions about both the upfront costs of construction, as well as the collateral total cost of homeownership. So in Nashville, Tennessee, for example, we've recently completed a cluster of high-performance one-bedroom homes. In this project, we worked from beginning to end with the contractor on all technical aspects of home performance. And as just one example of this, we utilized an initial blower-door test, not as a measure of performance as we usually would in the business, but rather simply as a tool to help everyone on the project quantitatively understand the importance of doing things right relative to air sealing, and to communicate with the subcontractors early in the construction process of what doing things right really means. So by engaging a builder directly with the energy consultant and HERS rater, which is really simple to do, and then evaluating building performance at several key moments during construction, we were able to just about meet 2018 Energy Code expectations while only utilizing 2012 Energy Code requirements for construction. This was really an important learning opportunity for everybody involved, because as the impact of doing things right or otherwise focusing on construction means and methods and not just the utilization of advanced materials and assemblies is key to increasing building performance without increasing construction costs. So the questions that we're going to talk about in a little bit, these questions about what a house costs to build, they're really important. And as an architect, continuing to innovate in this area is extraordinarily valuable. But in addition to asking what it costs to build a home, we've also got to ask the question, what it costs if we don't. It's in really the answers to this question where I think we're likely going to find the most useful innovations of all. Because while the cost of providing equitable access to high performance, healthy housing really may seem extremely high these days, and it is, the cost of our continued inaction in addressing this challenge will likely prove to be devastating. So thanks, everybody. I look forward to your questions, as everybody does, and the conversation that follows.
Thank you, Rusty. Thank you to all of you. And I just want to remind everyone to please feel free to add a comment or question in the chat if you're watching live on YouTube, or tweet at BPC_bipartisan, or using the hashtag BPC Live. I have a few questions prepared, but in the interest of time, we'll try to make sure everyone's questions are asked. One comment that we did receive was that there was no mention of issues about, and I think this one is more for you, Mark, there were no mention of issues on land lease communities and rent spikes. Can you address that a little bit, please?
Certainly, I'm happy to. You know, land lease communities are kind of unique in the manufactured housing world, where you own the home and lease the ground underneath it. It's kind of a unique niche. Really what we found is that increases in lot rent is what we're talking about when someone rents the ground underneath the home. Increases in lot rent are rising at a lower rate than apartments in a given market area. And so our private landowners are doing a great job of controlling those costs. By and large, there are unique situations where market conditions force changes to rents. It's important to realize that in a housing cost formula, there's a couple of things that go into it. One is the cost of the materials and the construction, and another is the cost of the raw land, right? And you get into scenarios where you discuss what's the highest and best use of that land, or what's the tax basis for that land, and that's very different answers if you're in rural Alabama or in the southeast part of the country where our industry is strong, versus on the coast or something like that. So there's a lot that goes into it, and I'm happy to have any further discussion with anyone on it.
Great. Thank you, Mark. We have another question. Is there funding to develop a hybrid program that involves the use of trade schools training and modular manufacturing production in a nonprofit setting, decreasing the cost of labor and materials? I think almost any of you could answer this, but I'm going to toss it to Rusty.
Hey, thanks, Erica. Yeah, we're actually involved in a project down in the Panhandle of Florida, which is a collaboration between us, local Habitat for Humanity affiliate, and the local certified trade program. Normally, those certified trade programs, they do a lot of their certification clock hours in the laboratory, where they work in the school and you know, sort of build things in the lab, and then they take them apart, and the next group of students come in and build them. What we're doing there is the students are actually performing what would, in the traditional Habitat model, be they're the volunteer labor on the project while they're working to construct the homes for the affiliate. And in that way, they're sort of getting their clock hour credit, you know, while they're actually working on a real project that hopefully will have real impacts in their community. Projects like that are really important, not just because of building the trade, but that project is a disaster recovery project from Hurricane Michael that came in, you know, now almost 3 years ago, still working to recover there. And typically in those really hard hit under and uninsured communities, that work can go on for years. So having that ready and willing workforce there in the community that's really spooled up, not just on construction, but on high performance and resilient construction. That's the kind of overlay that we bring to the program, is really part of the community's disaster recovery and mitigation plan for the whole community. So it does a lot more than just build houses back better and those sorts of things. It actually better prepares a community to respond the next time to these kind of disasters that we know are going to continue to come.
Thank you. So Judith, I have a question for you. So we understand that mass timber holds the promise of more cost-effective housing. Well, one question that I've had is how have the current run-up in lumber prices, as well as some of the lingering supply chain disruptions, how is that affecting cost with mass timber? And how do you think that's going to be longer term?
Great question. And in a way, we're addressing it by using mass plywood, which is almost entirely locally sourced. Furs Lumber owns something like 17,000 acres of their own forests, and also sources almost all their timber supply locally. And veneer products use 70% of a tree versus lumber products. But so during the run up in lumber prices, paradoxically, MPP has become comparatively more affordable. It went from about $34 a cubic foot to $37, so less than a 10% increase, while lumber, which is used in light wood frame and in cross-laminated timber production, has gone up. It went up some huge amount, like, several 100%, and then back down again. It's kind of been bouncing around, but it's still at least 50% higher. So, but it's something that we look at all the time in Oregon is the supply chain. And we think that by opening up more forests for restoration projects to reduce wildfire, fuels, we can also increase the fiber supply, especially of small diameter logs that can be used to create mass timber. Mm-hmm.
You, Andrew, I have a question for you. In your presentation, you talked about some of the challenges or what regulators and policymakers can do to help expand innovation in the sector. Could you speak to that for a little bit?
Sure. Yeah, I think part of it is what we heard a little bit from Mark is kind of an openness to different types of technologies that are going to bring affordable housing. An openness to that in terms of the local market and the local zoning, and working with people when they're trying to integrate and adopt new technologies. So with the 3D concrete house, we had extensive meetings with local partners to just try to make sure that this was a good fit. And we wanted to just see early on in kind of a roundtable discussion, what are the different parts of the zoning or the code that could be an issue, and how do we make sure that we answer that before we get in there. So I think it really is about communication and partnerships and trying to work together. You're going to have some instances where certain technologies are more suited for certain zoning, I think. And that's one of the things that, that we're really pushing is this is a broad toolkit that needs to have a lot of different options and a lot of different conversations as to what might be the most appropriate to help. And Rusty's right on. Drive efficiency, drive the quality, especially the long-term operation. It's one thing to provide affordable housing. It's another thing to provide housing that's affordable to operate longer term. And so all of these, I think, kind of would make certain technologies more appropriate in certain settings. Having those conversations and trying to figure out how to work with local authorities to make it work, that's pretty critical.
Thank you. Mark, we have a couple of more questions, or one on manufactured housing. This one's from James. It seems home manufacturing is not as prominent in coastal markets. As you mentioned, you're really strong in the Southeast. Could you go into some of the reasons that is, and does regulation play a role in that?
Regulation, for better or worse, plays a role in everything. Part of it is land costs that I mentioned also. If you get into the coastal markets, the cost of land is significant. And the home buyers in coastal markets generally are at a much higher price point than most manufactured home buyers are historically. And I mentioned our industry is responding with this kind of crossover home that adds some site-built features to it and kind of boosts the curb appeal. As Andrew mentioned, is working with the local governments and the local markets. And for us, one of the innovations that we've come up with is really to try and build our homes that fit in any neighborhood in America. We haven't always done that, but that's one of the things that we've been working on. But certainly regulation and zoning and costs are big factors in why we're not as strong on the coasts.
Thank you. Another question, and this one is for Judith. Could you provide any specific examples of affordable multifamily properties that have been renovated using CLT for retrofitting? And if so, who builds the panels?
I think the answer to that is no. What we're doing is innovative and will be brand new. It's based on a project you may have heard about in the Netherlands called Energy Sprong, where they've been doing laser scanning of existing facades and completely pre-manufacturing facades to put on buildings, which are covered in fake bricks, which is unfortunate. But here it's slightly different because, especially in the West Coast, because of the seismic issue, is that we really have to do more than just insulate the envelope to really make the housing resilient. But no, it has not been done yet in terms of that retrofit. There is a little bit, there have been one or two projects that have used CLT panels for seismic retrofit only, and that's basically been internally in the units. But we are looking forward to, many projects in the future that will be employing these technologies. We hope ours will be the first.
Great. This one, I'm not really sure. Whoever would like to jump in can, but one of the things about 3D printing is that it uses usually like a proprietary form of concrete, which is considered a very energy intensive material. But could you help us understand the differences in cost and sustainability when it's being used in 3D printing? Anyone?
Well, maybe that's for me. I don't know, because of our recent work. Yes. So yes, concrete is very carbon intensive. What you're seeing is, and this is the hope, that when you have innovation, with it comes other innovation, supportive, or innovation that is from other industries that want to be involved. So you're starting to see, and really the goal is to reduce the content of the cement, right, as an additive. But that's a problem in terms of strength and durability. So one of the things that we're seeing is hempcrete. We're seeing hemp mixed in with to replace cement, and it's very early on. There's a lot of tests that need to happen. You're seeing different soil mixtures as well. In terms of affordability, and I think the future is you're going to see a lot more polymer-based mixes as well. So you're going to see some use of polymers in the mix itself. Long term, in terms of affordability, the houses that I've worked on are very early and they're experimental. So just like any prototype, the first house was expensive. We saw a lot of efficiencies to the second house. And that second house, it was a 1,200 square foot house. It was produced around $160, $165 a square foot, something like that, in that range. And so the goal is to try to just continue to get that down. I think that group that we've been working with is getting ready to print something like 200 houses. And I think at that scale, you'll start to see more and more of efficiencies in cost and schedule, things like that.
Thank you. This one I'm going to turn to Rusty. You mentioned your work in areas such as Nashville. So states we think of as typically rural, but all states have rural and urban areas. And have you found things that have worked particularly well in technology transfer that you could discuss?
Yeah, well, it's not so much relative to technology transfer, but a lot of our work does have to do with, kind of understanding, because we do, work all over the United States. A lot of our work has to do with, kind of what's universal within housing procurement and what's particular. And there are some things that are, opportunities and challenges that are unique to both urban and rural places. In rural places, you know, and you're right, every place has got rural places. 97% of America is actually rural, and about, you know, over 60 million people live in rural places. So it's a lot of the U.S. You know, a lot of times you sort of think that it might be easier to do things there. And we find that folks in rural places are very innovative and entrepreneurial. We've always had to be. You know, if you need something, you make it. If it breaks, you fix it. And so that kind of attitude, it comes into projects all the time. But because there's actually not always a whole lot of regulatory oversight, as architects, it actually elevates the responsibility to, again, do things right. It doesn't remove that responsibility or lessen it. It actually increases it. It brings more of the responsibility into the design and oversight of a project to make sure that you're doing things right. A lot of the challenges come from infrastructure problems in rural places. The inability to communicate is a challenge. We use a lot of communication technologies. Communication is the place where so much innovation can happen. But what's been great is, in some ways during the pandemic, a lot of us have learned to communicate in different ways than we were just a few years ago. So even that's begun to help a lot. The access to technology and know-how is often missing. So for example, when we're trying to build to a high performance label, even if it's something like Energy Star, for example, you've got to have an Energy Star certified contractor that to install and certify that piece of that human comfort system in the house. We had a project where the closest installer was an hour and a half away, and it was going to bring about a $2,000 premium to the project just to build an energy efficient home. Well, so what we wound up doing was we actually reduced the system down to a ductless system that could actually be certified in the factory. So it reduced that kind of need to have that level of remote oversight. And we actually got the project in under budget. So again, it's sort of not technical, it's not sort of necessarily technical innovation. It's actually sort of looking at where you are and kind of meeting folks where they are and understanding the kind of the range of opportunities that you have in front of you to do things differently. I mean, one of the terrible things about single family houses is that you deliver them one at a time in a kind of a highly customized way. One of the awesome things about single family houses is exactly the same thing. You deliver them one at a time in a highly customized way. And it's actually leveraging that as an opportunity for innovation is, I think, where a lot of our work lies.
Okay, thank you. It looks like we're getting close to wrapping up. So I just want to ask if we have any more comments or questions from any of our audience who are on here, because we have a few minutes left. But I'm not seeing anything. So I will just say, I want to thank everybody for participating today and taking the time to share their knowledge with us. As I mentioned earlier, this is the 4th webinar in our series on the need to increase the supply of homes in response to the nation's housing affordability crisis. So please mark your calendars for April 21st for our next webinar, which will examine corporate initiatives to boost housing supply and affordability. Shout out to Judith Shine and her project, which touched on that, and recognizing how corporate America has been both affected and is affected by fast rising housing costs. So thank you all for joining us today, and we hope to see you next month.